All right, 11.3, this is geometric sequence and series. So yesterday, in last lesson, we learned that arithmetic sequence had a common difference, which basically means from one term to the next term, we're going to add. Well, in a geometric sequence, a geometric sequence is a sequence in which the ratio of each term to the previous term is constant. Now, what we mean by ratio is, and you got to remember about geometric is, we're going to multiply. So if the first term was 2, then I could have 6, then I could have 18, and so on. So basically what I'm doing from the first term to the second term is I'm multiplying by 3, okay? And I believe the next one would be 54, okay? And it just keeps going. You just multiply by 3. That term, when we multiplied times 3, is called a common ratio, okay? It's the constant ratio between the consecutive, okay? And a geometric series is just when you take that, just remember what series is, you take that summation, or you take that sequence, and you just add it up. That's it. You just add them up, okay? All right. So in these first few examples, we just want to decide, is it a geometric sequence? Okay, so remember we have to do something each time that we go. So I always decide, oh, wait a minute. If I go 1 times 2, yeah, I can do that, times 2. So I got to do the exact same thing in times 2. Well, 2 times 2 doesn't give me 6. So this first one is not geometric. Okay? Okay. Now, on part B, ooh, wait, this is kind of challenging, because going from 81 to 27, I can't multiply anything. So basically, especially when you're starting with big numbers and you're going from large numbers, think about how could you go from 1 to 3? Well, I could divide by 3. And anytime you divide by a number, that's the same as multiplying by a fraction, 1/3. Okay, so if I take 9 times 1/3, do I get the exact same thing? Absolutely. 27 times 1/3, do I get 9? Yes. 81 times 1/3, can I take 81 divided by 3? Absolutely. So yes, this one is geometric. Okay. And you could have also taken, remember 27 divided by 81? And I wouldn't suggest dividing those out because 1/3 is an ugly decimal. But you can divide, I can divide both of these by 9, which gives me 3. Divide that by 9 gives me 9. Oh, that still simplifies down to 1/3. And just got to make sure that's consistent. The next one I would do 9 over 27. Oh, I can divide both of those by 9. And you end up with 1/3. Okay, so yes, that last one is geometric. Okay. So just like when we write the rule for arithmetic, I think this one actually ends up a little easier, but the terms are a lot the same. So remember a sub n is going to be my nth term. Okay? And this is not something we're expecting you to memorize the formulas. We are expecting you to be able to use them. Okay? A sub 1 is your first term, and r is your common ratio. And n is the number of term. So in other words, if I'm looking for the 8th term, then that would be 8. If it was the 10th term, it would be 8. Okay? All right, so in example number 1, we want to write the nth term. We want to write a rule for the nth term of the sequence, and then we actually want to find this is. So remember, when we find the rule, it's a sub n equals, and since this is a geometric, and the directions will actually specify, a sub 1 times r to the n minus 1. Well, my first term is negative 8. Okay? So a sub n, negative 8. And remember, I'm going to take 12 divided by negative 8, negative 12 divided by negative 8 to find out what that common ratio is. So my a sub 1, let's do this first of all, was negative 8. I need to know what my r is. So is that a nice fraction we can... Because if it's a nice fraction, let's just turn it to the decimal. Absolutely, ends up 1.5. Remember, a negative over a negative is a positive. And I'm writing the nth rule, so in this case, my n is going to be n. Okay? So make sure you put a times in there. R is 1.5, and I'm leaving n minus 1. And there is no simplifying to this one. That is it. Okay? So the second part of this is I wanted to find a sub 8. Okay, so now all of a sudden the only thing that changes on this one is my I want to use this rule. So, but my n is 8. Okay, so I get negative 8 times 1.5 to the 8 minus 1. And so this just ends up, and I can use a scientific calculator to find this. I could do negative 8 times 1.5 to the 8 minus 1 is 7. Okay, close the parenthesis, and I get negative 136.68. So my a sub n is negative 136 point, and let's just put a couple decimal places. Actually 0.6875. Okay, as your answer. Okay, so go ahead and try the next one. This one, we want to write a rule for write a rule for the nth term of the sequence 5, 2, 0.8, and 0.32, and then we're going to find a sub 8. Okay, so remember, find the rule as a sub n equals a sub 1 times r to the n minus 1. So our a sub 1 is 5. Our r, so we're just going to take 2 to find our r. We're going to take 2 divided by 5 and see if that goes nice and pretty and evenly. So 2 divided by 5 gives me 0.4. So my r is 0.4, and my n, I'm looking for that one. So my actual rule is 5 times 0.4 to the n minus 1. That's it. So if I wanted to find the 8th term, okay, to find a sub 8, I'm going to do 5 times 0.4, and I just plug in my 8. Okay? So it ends up being, use a scientific calculator, ends up being 5 times 0.4 to the 8 minus 1 is 7. Those are parentheses. And I get 0.008192. Okay, as my answer. Okay. All right. So in the next one, it says one term of a geometric series is a3. Okay, remember our formula was a sub n equals a sub 1 r to the n minus 1. Our common ratio is 2. Write the rule for the nth term. Well, in this case, we've got our third term. So our 3, remember our a sub 1 is what we're actually looking for. Our r is 2. That's a multiply. And our n is, well, this is our n, remember? So 3 minus 1, I'm going to put a 2 in there. And that term is the 5th term. So to find our a sub 1, it's just 5 equals, 2 squared is 4, so this would be 4 times a to the first. Divide by 4, and I find out that my first term is 5/4. So I already have my r. My r, remember, is 2. So I plug all my information in. So to get my rule for my a sub n would be a sub 1, which is 5/4, times 2 to the n minus 1. Okay. All right, so just like on arithmetic, we can actually find the sum of these. And so this notation stands for the sum of the first n terms. This is the first term. R is your common ratio. Both r's actually. And n is the number of term. So if I wanted the first 10 terms, then it would be, that number would be 10. Okay, so let's take a look at the next one real quick. So consider the geometric series for the first 10 terms. Now if you'll notice really quick, okay, so my series was s sub n equals a sub 1, 1 minus r to the nth power, all over 1 minus r. So I'm looking for the first 10 terms. So my a sub 1 is 1. It's the first term. My r, well, 5 divided by 1 is what? 5. So that's my common ratio is 5. 25 divided by 5 is 5. So my common ratio is 5. And my n is the number of terms I'm looking for. So in this case, it's 10. Okay, so I just simply plug it in. A sub 1 is 1. 1 minus r to the 5th, so it'll be 5 to the 10th power over 1 minus 5. And this would be a good idea. This is where, you want to use a scientific calculator. So you're going to do 1 times, and then 1 minus 5 to the 10th, divided by. And it's a really good idea. Let's do this. Make sure that we include that the calculator knows that it needs to actually divide those, find that number and divide those first. Okay? Oops. So let's add another set of parentheses in here. And I think we've got enough. So you hit enter, and you find out your answer is 2,441,406. Okay? So go ahead and try the last one. Okay? So consider the geometric series 4, 12, 36, 108, and 324. And we want to find the sum of the first n terms. So here's our formula. So a sub 1 in this case, it's our first term, which is 4. Our r, 12 divided by 4 is 3. And our n is going to be 15. So we're looking for the sum of the first 15 terms. A sub 1 is 4. We're going to do 1 minus 3 to the 15th over 1 minus 3. So put that in the calculator. And I get 4 times, and let's do a double parenthesis, 1 minus 3 to the 15th. And then divide that by 1 minus 3. Oops, I forgot I set a parentheses. And finish it off, and we find out that our answer is 286,978,12. So our final answer is 28,697,812. So as a quick recap, remember when you're doing geometric series to find the nth term, a sub n equals a sub 1 r to the n minus 1. And to find the series, it's the first term, 1 minus r to the nth term over 1 minus r.